In this lesson, we're going to look at the individual gas laws, and we'll also clarify which ones are direct and indirect relationships. And we will also identify the variables that are held constant. So when we're looking at the individual gas laws, what we see is that we're only looking at two variables. Some of you may have talked about the ideal gas law in another chemistry class. We're going to focus on these individual laws. So here we're going to show our individual gas laws. We have Boyle's, Charles, and Avogadro's, and I'm not so worried about you knowing the names of these laws. What I'm worried about you understanding is the equations, how they're set up, and the relationships that happen in them. And so first we're going to look at Boyle's law, and we see that it includes pressure and volume, and what that tells me is that moles, okay, and we're going to call that N, and temperature are the things being held constant. And what we can also see, which may not be completely obvious from the way the equation is written, but this is actually an indirect relationship or an inverse relationship. So as the pressure goes up, the volume is going to go down. But what we're looking at here is that pressure and volume in one scenario is going to be equal to P times V in another scenario. So if the pressure increases in going from P1 to P2, the volume going from V1 to V2 must decrease. The second example is with Charles' law. V1 over T1 equals V2 over T2. The two variables that are not mentioned here, which are held constant, are N, again moles, and pressure. And what we see here is that this is actually representing a direct relationship. Okay? If V1 increases as it goes to V2, T1 will also increase as it goes to T2. And so we see this as a direct relationship between V and T. The last one we'll look at is Avogadro's law, and the two variables that are missing here in the equation, and the reason they're missing is because they are constant, are our temperature and our pressure. And this is also a direct relationship. If the volume increases, going from V1 to V2, the number of moles of gas must also increase as we go from N1 to N2. In the next lesson, we'll actually look at our worked examples. We'll go through a couple of examples using the gas laws in these calculations. The big thing we have to remember, especially with our Charles law here, is about the temperature. And temperature must be in Kelvin. Okay. So in order for this relationship to work out mathematically, it has to be in units of Kelvin. With the other units, pressure and volume, it's not essential that they be in a specific unit because as long as the units are the same as one another, because the way we convert between volume, say milliliters to liters, is we divide by 1,000. The issue with temperature is now we have an addition involved, or either adding or subtracting the 273, and so we have to make sure we have our temperature in Kelvin.